Desertification, a persistent and serious issue, has created numerous difficulties for Burkina Faso, a nation already facing a multitude of other challenges. For decades, the country's arid regions have endured increasing pressure from desertification, with strong winds blowing sand over fields, clogging drainage systems, and burying young trees and forests. When shifting sand dunes encroach on farmlands, farmers fall into a vicious cycle of crop failure, poverty, and migration. The consequences are not merely temporary crop losses, but also a long-term degradation of the soil. The thin layer of humus is blown away by the wind, moisture evaporates quickly, and fertility declines, making it even more difficult for the land to recover in subsequent seasons. Traditional solutions like concrete barriers, large dams, or massive irrigation projects often require billions of dollars in investment, have long construction cycles, and entail significant operational and maintenance costs. For a country with limited resources like Burkina Faso, a heavy on concrete, heavy on debt approach can easily lead to a cost trap. Large-scale projects are difficult to replicate and not easy to implement with community participation. In this context, President Ibrahim Traoré's Rubber Tire Mountains initiative emerges as a low-cost approach that can be rapidly scaled up, leveraging a readily available resource, waste tires. Simultaneously, this project opens up an opportunity for a circular economy, from waste management to material processing, infrastructure development, and clean energy production. In terms of engineering principles, wind-driven sand forms streaks and dunes. To reduce wind speed near the ground, a classic solution is to use porous sand fences. These fences don't block the wind completely, but create a turbulence effect that reduces wind energy, causing sand particles to settle. When stacked and anchored with connecting rods or steel cables, rubber tires function as effective semi-permeable barriers. Tires have several advantages. They are mechanically durable, resistant to impact, and have good thermal expansion properties. Their weight and geometry are stable, and they can be arranged in modular patterns to suit various terrains. Furthermore, they are easy to reposition as dunes shift and require simple maintenance. Instead of building a single long, expensive wall, the project uses multiple parallel tire barrier strips, creating a sand belt with a spacing of 20 to 60 meters, depending on wind speed and dune height. In high wind areas, tires are arranged in a honeycomb pattern to trap and stabilize the sand, forming controlled catch basins where wind-breaking trees like native acacia, gum arabic, or thorny shrubs can be planted to lock the sand with their roots. To prevent tipping, sliding, or undermining, a shallow foundation trench is dug, lined with geotextile fabric, and filled with crushed stone or sand inside the tires to increase their weight. Galvanized steel or composite stakes are used to anchor the tires to the ground. In areas prone to erosion, geotextile mats and horizontal tires are used to disperse loads and reduce the risk of undermining by floodwaters. This project also incorporates a hydraulic component. In arid regions, rainfall is often short, intense, and localized. Without reservoirs, water quickly runs off, carrying away mud and nutrients. The honeycomb tire structures can serve as small-scale micro-catchments. On slopes, tires are arranged along contour lines to create small terraces that retain rainwater and reduce erosion. At the base of slopes, they form silk traps to collect sediment. This settled soil can then be returned to the tree planting basins, increasing soil fertility. Combined with infiltration trenches, the tires help rainwater gradually seep into the soil, recharging groundwater and reducing flood peaks. In low-lying areas, a network of small, shallow ponds, 10 to 30 meters in diameter, 1 to 2 meters deep, lined with tires, helps prevent bank erosion and creates water points for livestock and crops. The water retained in these ponds, combined with biological filtration, can be used for irrigation and, after treatment, for some domestic purposes. The integration of technology and the environment is further demonstrated through the solar city and agrivoltaics models. Solar power not only provides clean energy, but also improves the microclimate. Beneath the solar panels, shade reduces water evaporation. If the panels are installed 0.8 to 1.2 meters above the ground, drought-resistant grasses or legumes can be planted to increase soil cover. This project is not just about waste management, but also about building a circular economy value chain. Collecting tires requires an efficient logistics network. Tires are sorted. Type A for infrastructure, Type B for grinding into material, and Type C for safe storage. Ground tire material, or crumb rubber, can be mixed with asphalt to create rubberized asphalt, which is more durable, quieter, and extends road lifespan. Rubber bricks, pads, and shock absorbers can also be produced. The project emphasizes not burning tires to avoid toxic emissions. If closed-loop pyrolysis technology is used, it is only considered a supplementary branch and must be accompanied by strict control of emissions and waste. Furthermore, the project creates numerous jobs. The implementation phase requires thousands of local laborers to dig trenches, stack tires, and plant trees. The operation and maintenance phase requires teams to monitor wind, sand, and rain, clean solar panels, inspect barriers, and dredge silt traps. The industrial chain for tire grinding and rubber product manufacturing will create a new class of local technicians. Short-term and medium-term training programs will help residents gain new skills. Environmental risk management is also a priority. Improper tire arrangement can create stagnant water, providing a breeding ground for mosquitoes. The solution is to drill drainage holes and line the structures with geotextile fabric to ensure rapid water runoff. Risks of chemical leaching and fire are also strictly controlled through the use of separation layers and fire breaks. Institutionally, the project requires an interagency steering committee, clear technical standards, and a wind-sand flow map to prioritize intervention areas. Financially, it uses a blended model. State funds for public infrastructure, public-private partnerships for factories and power farms, and climate funds for planting activities. A payment-by-completion mechanism also incentivizes implementers. Community-managed tire barriers are handed over to local cooperatives with maintenance contracts that include rewards and penalties. This project has learned from the experiences of other countries. Many have faced the consequences of tire graveyards with large fires and pollution. The key insight of the Burkina Faso project is to turn disposal costs into utility value, making waste tires construction materials that participate in the energy and infrastructure value chain. The difference is the project's direct application on a large scale in desertified areas, where tires become a core construction material, combined with tree planting, water retention, and solar power to create a multi-layered ecological and economic defense system. Traoré's vision is to turn Burkina Faso into a Dubai of the sun, not based on oil, but on the sun, soil, and recycled waste. This project demonstrates the ability to reorganize resources. Waste becomes material. The desert becomes a power plant. Rain becomes a water source, and idle labor becomes a skilled workforce. The rubber tire project is not a simple plan to stop sand. It is an integrated design where tire belts serve as sand fences, tire basins retain rainwater, and solar power provides clean energy. The circular tire economy creates a new industry, while institutions, finance, and the community are mobilized to ensure success. Instead of polluting the environment by burning tires, they are transformed into a lever for development. Instead of building a few large projects, Burkina Faso is building many small, modular, smart, and scalable ones that require less capital but more innovation. And instead of viewing the desert as a cruel destiny, this nation is learning to turn it into a strategic asset to create electricity, water, land, jobs, and a new future. If this tire revolution is executed with discipline, transparency, and public participation, Burkina Faso will not only block sand and create power, but also transform waste into power, creating a development cycle that bears its own unique mark.